The goal of this example is to determine the difference between when we use energy and when we use momentum. In this example, we're going to use both, and it looks like we have two blocks that are basically on something that looks kind of like a half pipe. It is number 35 in your book if you want to follow along. The two masses have different masses, but they have the same height. So their potential energy is going to be mgh, that's what they start with, and there's no friction as they fall down. So they're not going to lose any energy. All of that potential energy is going to be converted to kinetic energy. So to find, the first thing we need to do, because they haven't collided yet, is to find out their velocities down here, right at the bottom. So we're going to assume they come all the way down that 5 meters, and they're right at the bottom. We're going to find how fast are they going. So if we look over here, we already have been told that there is no friction, so we're going to have no work lost. And then we can see that they start off at the top and they're being held there, so they're not going to have any kinetic energy at the beginning. And then at the bottom where our datum line is, we're not going to have any potential energy. So all of the potential is going to turn to kinetic. And once we find our two velocities, then we're going to come down here and we're going to say what happens when they hit. What happens when they hit? Very sorry about the handwriting. It's really hard to work with the stylus, but I'm getting a new one. Okay, so let's go back here. And we're going to have all of that kinetic energy coming down, and now they're going to be down here, and they're going to hit each other. So they hit with a certain velocity that we determine ahead of time, and then we come to this equation right here to figure out what they end up with. All right, so I think that you can find these two momentums, and then the ending momentum you say, but we have two different velocities and they stay separate and they have different masses, so how do we figure it out? Well, if you remember from the book, we wrote down an equation that looked like this: V1 initial minus V2 initial equals V2 final minus V1 final. And if you remember that this works, or the only reason that we're using this one is because in the problem it says it's a head-on elastic collision. Elastic. Okay, and this equation comes from, if you remember what we wrote or what we saw in the book, this equation comes from kinetic energy being conserved and momentum being conserved. And so they just did a little bit of algebra and they wound up with this thing here. Okay, so what we're going to do is we know the two velocities ahead of time. That's the same ones. And these are the same two unknowns that we had in the other equation. So we're going to have to solve two equations, two unknowns. Let's go back over here. Once we found our ending velocities, let's go back here, then these blocks are going to bounce and they're going to go back up and they're not going to lose any energy again. So then we have to go back to energy, and we're going to use an equation just like this one, only now our starting position is the bottom and our ending position is the top. So the second time, we're going to start off with zero potential. We're going to have kinetic. We're going to end up with potential and no kinetic. So I hope that helps.